Time is like a river. You cannot touch the same water twice because the flow that is passed will never pass again. Time is very precious. Do value your time. Do not waste your time. Hello everyone. Myself Nigar Sultana. I welcome you all to RN Digital Learnings. In this video, we are going to learn the merge sort, which is based on the divide and conquer technique. So now let's move on to the computer screen.
Let's begin with the merge sort. It follows the technique of the divide and conquer. Before we begin what is merge sort, let's understand what is a divide and conquer technique. This divide and conquer technique involves with the three steps. First, we will be dividing an array or a problem into the sub-problems. Next thing is we will conquer. Conquer in the sense we will recursively solve each sub-problem or each small array. Then we will combine. Combine in the sense we are going to merge the solution of each sub-problem. So this is your divide and conquer technique. Same procedure will be applied for merge sort and quick sort. So merge sort is one of the example of divide and conquer technique because it follows these three steps. I'll repeat with this. Divide and conquer involves the three steps. First one is a dividing, then conquering, then combining. Divide in the sense we are going to divide the problem into the sub-problems. Conquer means recursively we are solving the each sub-problem or the sub-arrays. Then we will combine whatever we have got the recursively solved arrays, we will combine that to give an appropriate solution. Now let's begin with the example of this merge sort. So in this merge sort, here first we will divide the sequence into the two equal parts. Then we will recursively sort the element of the left part. Third step is recursively we will solve the elements of the right part. Then we will merge the sorted left and right part. So this is an example for the merge sort, which begins with the index 0 to 6. That means we have 7 elements in an array. Now this array we are going to divide by some mid formula. Then recursively we will solve the left part and the right part. Then we are going to merge the subarrays. So now we have 7 elements here. How will you divide this? Based on mid value. So here we have the mid value as 45 because 35, 10, 15 will come towards your left part. 25, 20, 40 comes to my right part. Now 45 is my mid element. So there is one formula to find the mid, that is low plus high divide by 2. That is we have the low value as 0 and high value as 6. 0 plus 6 is 6 divide by 2. That is we get 3. So 3 is our mid value. Now how will you take this to the left part? So from 0 to mid value we will be considered to be in the left part. Then from the mid plus 1, that is 4 to high will be my right part. See. Now this sub array, that is this is my left part and this is my right part. This large array is been divided into the two parts. 35, 10, 15, 45 will comes to my left part and 25, 20, 40 will comes to my right part. Again we are going to divide this sub arrays into the smaller arrays. Now let's see. Again 35, 10, 15 and 45. 35 and 10 will be to my left part and 15, 45 will be my to the right part. Similarly, the right part of an array, that is 25, 20, 40, again that will be divided into the two parts. 25 and 20 will be to my left part and 40 will be to my the right part. So again these subarrays will be subdivided again. 35, 10, 15, 45, 25, 20. So what happens? Now the first step is done with this. We have divided the sequence into the two equal parts. Now we are recursively solving this subarrays and we are going to merge. Let's see the procedure. We will compare this 35 and 10. Already we have divided into the smaller subarrays. Further we cannot divide because 35 is one element, 10 is one element, 15, 45, all these are individual elements. Now we start solving this arrays and merging. When we compare this 35 and 10, 35 will goes to the higher position, 10 will come to the smaller position. Again 15 is the smaller one, 45 is the higher one. Next 20 is my smaller one and 25 is the higher one. Next, now these smaller arrays will be again recursively solved and we will merge into a single array. 35 will goes to the second position, this 10 will be in the first position because 10 is a smaller than these two subarrays, 10, 15, 35 and 45. Similarly, we have 20, 25 and 40. Next, these two subarrays will be merged again to give a sorted array. Now all my elements are being arranged in a sorted form. Finally, we got our sorted elements of an array that starts from 10, 15, 20, 25, 35, 40 and 45. Now let's understand the logic how we will calculate all these things. So in this logic of the merge sort, we have used two functions. First one is your merge sort and one more is your merge. Now first, when we execute this merge sort, what happens is we take an array, we'll observe for the low and the high, then we will calculate the mid. How will I calculate the mid? That mid can be calculated by, as I have told you, low plus high divided by 2. So if this is my low 0 and this is my high 6, 0 plus 6 is 6 divided by 2, that is we will get 3. So I have divided. So based on that formula, I have divided this array into two parts. Again, so what I'll be doing next, I'll be calling this merge sort again. So we have a, low and mid. Why do we use this? So now this is my low and this is my mid. So again I'll be using that merge sort to solve this subarray, and this part can be solved by this function. So this is my merge sort a comma mid plus 1 comma high. So now my mid plus 1 is this part and high is this one. Now this mid plus 1 will be low to me and 6 will be the high. Next again. So similarly, we will be calling this and we will be solving each subarrays into the smaller or the individual arrays. Now next part is recursively solving this left and right arrays and merging them. So this is the function called for merge sort. In this for the merge, when we solve this merge sort for the this is for the left part and this is for the right part. When we recursively solve this, next we are going to merge this. So we have another function for this merge. So this is the logic for the merge function. We will be taking an array low, mid and high. So initially what we will be doing, we have three variables I, k and j. So the I value will be the lowest one, that is 0, and k is the variable we will be using for the sorted arrays. Next we have j. J will be assigned for the mid plus 1 because that is separate array. So now this I and j are the variables. So this I is a variable for the left part, j is a variable for the right part and k is a variable for the new array. So now let's understand this. First we need to compare this I value is lesser than or equal to mid and j value is lesser than or equal to high. So I'll be explaining this part with the help of an example. Be ready to learn the tracing of the merge sort. So now I'll be comparing this a of I with a of j, that is the first element of the left part and the first element of the right part will be compared with each other. Now if I get that first element of the left part is lesser than the first element of the right part, then I'll be storing that element into the new array. Then I'll be incrementing the value of I as well as k. If it is not lesser than this first element of the right part, then I'll be storing this part into the new array. Then I'll be incrementing the value of j and k. This part is used when we have few more elements left into the right part or the left part. To copy those, we use this part of coding. Don't worry, I'll be explaining each and every part with the help of an example. As I have told you, I'll be initially placing the value of k into the low. So this is my new array, that is k is equals to low. So low is my 0. This is my new empty array. So I'll be storing the value of k as 0 because this is the low of the new array. Now I is equals to low, as I have told you. Suppose, so in this part it's very easy, just we need to compare this and we need to assign the values, isn't it? Now I'll be taking the example of these two subarrays to explain the concept of merge. So this is I will be taken the value of the 0 of the left part. So this is my I and this is my j. Clear? And k will be the new array variable. So now let this be my left part of an array and this is my right part. It's quite easy to do this. So actually we start using this merge function from this part. Okay, but I'll be explaining the concept by taking this array. Yes, k is equals to 0. That is, see, first I'll be explaining with the concept of I is equals to low. So I is low for this and k is equals to low for the new array that where we will be placing the values of the sorted arrays. Now j will be my mid plus 1. Now I need to compare this. So first we have initialized this part. Now I'll be comparing this. So this part is completed. This is my initialization part. So this is the graphical representation of the initialization of the variables. So now let's understand this. I value is low. What is my low? That is 0. Next, I have told you j value is mid plus 1. So what is my mid? That is 4. 3 was my mid and 3 plus 1 is 4. K value will be low, that is 0. Yes. Now I need to check the condition of this while, that is I is less than, what is the I value? 0. Is 0 less than or equal to mid? What is my mid? Mid value is 3. Now let's compare this and we have one more condition, that is j value is 4. Is 4 lesser than or equal to high? High is my 6. Now this both the conditions are true. If it is true, I must check the if condition, that is a of I. What is a of I? A of I is my 0. A of 0 is lesser than or equal to A of j. J is my 4. So what is A of I? A of I is 10 and A of 4 is 20. Now let's take this. Is 10 lesser than or equals to 20? Yes, if it is true, what I must insert? So C of k, that is the new array, will have the A of I, that is A of I is my A of 0, that is 10. See, A of 0, that is C, this is my C of k value is 0 initially. So the k value will be 0 at the place of C of 0. C of 0 will be holding A of 0. A of 0 means it is 10. C of 0 will be holding 10 now. Next, I must increment I and k. If I increment I, initially the value of I was at the 0, now it will be incremented by 1, and similarly k was 0. When I increment the value of k will be equal to 1. See, I has been incremented. The value of I was 0, now it has become 1, and k was 0, now it has become to 1. J will be as it is. Now we are not using this part because already this condition is true, so we have executed this part. Now again, after this executing this part, we need to check the while condition again. Yes, now the I value is 1 because we have incremented the value. It has I is equals to 1 now. Check the condition of this. is 1 lesser than or equal to mid is 3, and we have j value as 4 lesser than or equals to 6. Now this is true, both are true. If they both are true, check the if conditions. Now a of I is lesser than or equals to a of j. What is my a of I? I is my 1 lesser than or equals to a of j. J is my 4. Now what is a of 1? A of 1 is 15. I must compare this 15 with 20. This is true. If this is true, I must execute this part. Now C of k value has been incremented as I have told you. Now k is 1. C of 1 will be holding a of 1 because I value is 1 now. C of 1, what is a of 1? A of 1 is 15. Now C of 1 will be holding 15. Then increment the value of I and k. I value was 1 initially. Now after incrementing, it will be 2. Increment the value of k. When I increment the value of k, k will be holding 2 now. See, C of 1 is holding 15. Then I have incremented the value of k. Now from 1 to it has become 2. I value has been incremented. Then j value will be as it is. So again run this while loop. Check the condition. Now as I have told you, I value has been incremented. I value is 2 now. Check the condition of this both. Is 2 lesser than or equals to 3? This is true. And we have one more, that is j is 4 lesser than or equals to 6. This is also true. Check the if condition. A of I is my 2 lesser than or equals to j is my 4. A of 4. What is a of 2? A of 2 is 35 lesser than or equals to 20. So this is false. So do not use this statements because this condition is false. Now I must execute the else part. What is the else part says? C of k, that is C of k is my, k has been incremented, k is my 2. C of 2 is equals to a of j. A of j is what? A of 4. That is, now C of 2 is holding a of 4. The a of 4 is 20. Next, increment j and k. The j value was 4. Now the j value is been incremented by 1, that is 5, and increment the value of k. K is been incremented, that is 3. See now, C of 2 is holding 20, then j is been incremented. Earlier it was at the 4th position, now it has been incremented and will be placed at the 5th position. I value will be as it is. We are not incrementing the I because we have been stored this 20, that is j value, into the k. So we are not incrementing or we are not changing the any value of the I, only we have incremented the value of j. Now the I value is as it is, that is 2. J value will be incremented and it is 5. Check the if condition, that is 2 lesser than or equals to 3, and we have j value, that is 5 lesser than or equal to high, it is 6. Both are true. Now check the if condition. A of I means a of 2 is lesser than or equals to a of 5. Now what is a of 2? A of 2 is holding, a of 2 is holding 35 and a of 5 is holding 25. So a of 2 is 35 lesser than or equals to 25. So this part is false. If this is false, no need of executing this part. Execute the else part. What the else part says? C of k. K value is 3. K was 3. Now C of 3 is equals to A of j. Now what is A of j? That is A of j value is 5. C of 3 is now 25. Next, increment j and k. J was 5, now it has changed to 6. K has been incremented, earlier it was 3, now it is 4. C of 3 is 25, then j increments from 5 to 6, I will be as it is, k has been incremented by 1. Again run the while loop. I value is 2, j value is equals to 6, k value is equals to 4. Now let's check the condition. I is lesser than or equals to mid. This part is true. We have one more, that is 6 is lesser than or equals to 6. Yes. So both are true. Check the if condition. A of I is 2. Is A of 2 is lesser than or equals to A of 6. What is A of 2? A of 2 is 35 and 40. We need to compare this 35 and 40. Is 35 lesser than or equals to 40? It's true. If it is true, execute this part. No need of executing the else part. What this part says? C of k, that is k is my 4. C of 4 is equals to A of I is 2. In C of 4, A of 2 is holding, that is A of 35. Increment I and k. So what is I? Initially it was 2, now it has been incremented 3 and k is equals to 5. Let's check. C of 4 is 35, I is been incremented, j will be as it is, k has been incremented from 4 to 5. In the next, I is 3 because it has been incremented, then j will be 6, k will be 5. Now check. Is 3 lesser than or equals to 3? And j is 6 is lesser than or equals to 6. Both are true. Check the if condition. A of I is 3 is lesser than or equals to A of 6. What is A of 3? A of 3 is 45 and A of 6 is 40. 45. So this is false. Execute the else part. C of k, that is 5, is equals to A of j. A of j is this 40. Increment j and k. J was 6, now it has become 7. Increment k from 5 to 6. C of 5 is holding 40 and j has been incremented, k is incremented by 6. So j was earlier at the 6, now it has incremented to 7. So now let's check the condition again. What is the value of I? I is 3, lesser than or equals to mid. Mid is 3 and we have j is 7, lesser than or equals to 6. This condition false because 7 is not lesser than or equal to 6. Then stop this while condition. So it has become false. Now we have few more elements left in the left part, that is 45 is left. If we have few more, we can add directly into the C array. Now let's see this. When do we execute this while condition? When we have few more elements left into the left part of an array, or if we have more elements into the right part of an array, we execute this part. Now let's check. So in this example, we will be executing this part because we have left few more elements into the left part of an array. Now I value is 3 is less than or equals to 3. Yes, in the C of k, that is k value is 6. C of 6, I will be holding a of 3, which is equals to 45. Increment the value of k. K was initially 6, now it has become 7. Then I value was 6, now it has increased by I value was 3, now it has been 4. Now what happens in the C of 6? It is 45. Increment the value of I. Now it has been incremented by I. Now I and j both having incremented. Now again check the condition of the while. I value is 4. Is 4 less than or equals to mid? This is false. Stop this part. So what happens here? The value of I will be directly given into the new array. So if we have few more elements left into the j part, so we will be using this while condition and we execute the statement. We use this for loop to copy this array elements from C to I. Initially we had the values of unsorted array in A of I, isn't it? Now we are going to place all these C array elements into the A elements. So let's start with the first initialization. I value is low. So now this is my C array. We have one more array as A. Now we are going to copy each and every element from C to A. I value is 0, that is low. Is 0 less than or equals to k value was 7. 7 minus 1 is 6. This is true. If this is true, enter into the loop. Now we have A of I, that is I is 0. A of 0 is equals to C of 0. What is the value of this? 10. Now 10 will be placed in the place of A of 0. Done. Next, increment the value of I. 1 less than or equals to 6. True. A of I, that is 1, is equals to C of 1. C of 1 is 15. 15 will be placed in A of 1. Done. Next, increment I. Is 2 less than or equals to 6? True. A of 2 is equals to C of 2, that is 20. Now 20 will be placed in A of 2. Increment the value of I. 3 is less than or equals to 6? True. A of 3 is equals to C of 3, that is 25. 25 will be placed in A of 3. Done. I is equals to 4. Now it has incremented. A of 4 is equals to C of 4, that is 35. 35 will be placed in A of 4. I is equals to 5. I is been incremented. Is 5 less than or equals to 6? True. A of 5 is equals to C of 5, that is 40. Increment the value of I. 6 is less than or equals to 6. A of 6 is equals to C of 6, that is 45. Increment the value of I. Is 6 less than or equals to, is 7 less than or equals to 6? This is false. So stop this for loop. Now we can see all the elements of C array is been placed in A array. All the elements of A are in ascending order: 10, 15, 20, 25, 35, 40 and 45.
Stay tuned to watch our next video on next sorting technique. Do like our video, share with your friends and do not forget to subscribe our channel. Thank you.